All right. Well, thank you so much for having me. This is the best organized conference ever. You guys are running ahead of schedule. So I'm really sorry I'm not there in person. Always sucks to do the online presentation versus being in person, but happy to contribute. Okay, so my talk is on unifying Ethereum and how we're using intents in ERC 7683, as well as this newly announced open intent framework to get intents everywhere. I want to spend a second just sort of framing the problem that we have here. Some of you heard me say this, but let's go into some of the successes Ethereum has had. So 4 years ago, there was our scaling problem. We just had a chain that was expensive and it didn't have that much scaling capacity. And when I think of the successes that Ethereum has had that is actually truly underappreciated, is that we aligned on a roadmap for how to scale Ethereum, how to make it faster and better, and executed on it. And many people in the room, many people at ETHDenver, these are all the folks that actually helped us have this like 100x scaling with lots more room to grow. If Ethereum's doesn't have enough scale now, you just add more L2s. And it's worked. The problem, though, is we've now introduced this new issue where we have all these chains, but they're all super fragmented. And this is the whole like Unify Ethereum campaign that we've been pushing, the whole ecosystem has been pushing. And increasingly, Ethereum and their leadership also think it's a major priority for the ecosystem. And it's worth thinking like, okay, like what's going on here? Why does this matter? And the way I look at it is like we go back in the day and you had like one chain and everything was so simple. It was so nice. You had one chain, you looked at your portfolio, you had assets on one chain, you clicked one button and you did the thing you wanted to do. And it didn't scale and it was expensive, but it was simple. And now we go forward and we have all the chains. Just a crazy number of things that we like can connect to, which is great. But all the chains mean we have all the different networks to connect to. We used to have to switch between the networks. MetaMask fixed that like 2 months ago. Thank you. And then we have all the tokens on all the chains, and it is confusing. It's a total mess. And so the goal here, if we want to unify Ethereum, what are the tools, what are the building blocks, what are the things that we need to do to make this mess all feel like one chain again? Yeah, there we go. Unify Ethereum. Jill Gunther from Espresso says this very well too. So I love ranting on that. So what are the components we need here? We definitely need some better app and wallet UX. That's not what I'm going to be talking about here, but I think it's critically important. We need account abstraction, which is going to lead into chain abstraction. A bunch of approaches to this. I think 7702 and the Pectra hard fork are going to be a big improvement here. And the thing I want to focus on is speed. It's like this fast bridging concept. So baseline statement, if we're going to make Ethereum feel unified, interoperability between all those chains I showed on the last slide, that interoperability needs to be fast. And I like to harp on this 2-second number. It's got to be 2 seconds fast. I don't totally make that number up. I've shouted about this on Twitter for a while, but 2 seconds isn't completely made up. It is like based off of what our friends at Google have done in Web 2 space. And they say, hey, if you're going to go around surfing the internet and a website takes more than 2 seconds to load, you have a problem. A website that takes more than 2 seconds to load is going to lead to huge like bounce rates. Psychologically, humans seem to want that we have a 2-second attention span before our minds wander and we want to do the next thing. So if I'm sitting there clicking a Web3 app and it's taking more than 2 seconds for me to do something, I'm gone. I'm into the next thing. So we got to hit this 2-second interoperability if we're going to make Ethereum feel unified. And from my perspective, and I think this is getting more and more well established, intents are really the only viable mechanism that can deliver us this 2-second experience going between blockchains. It's the only viable mechanisms that's going to get us there anytime soon. Okay, so how do intents work, and like what's the new stuff here that we're talking about? At last ETHDenver, working with our friends at Frontier Research, now like the One Balance team, we really talked about how intents look like a cake. I'm stealing this from Ankit's cake framework. But this has long been the way that Across has thought about our structure too. At the top, you have an application or a user creating an intent. This is what I want to do between chains. Then you send that intent to a solver network. This solver network is going to compete for the right to fill that user intent. And at the bottom, we have what I like to call our settlement layer. And the settlement layer does two things. One, it takes the intent from the beginning, it takes the user funds, and it escrows them on the origin chain. And then two, after it sees that the solver did in fact fill the intent, it releases those escrowed funds back to the solver. So this is basically like the safety mechanism that ensures that user funds will only get paid out to the solver if in fact they did what they promised they were going to do. All right. So like, how do intents work? I bet the audience knows this, but we'll do it in like 3 slides just to hammer home the points of like what's going on here. This is the user funds get escrowed on origin chain. This intent is broadcast to this network of solvers. They all see what's going on here. These solvers compete to send the user their funds, the funds the user wants, out of their own capital. So the solver is going to spend their own money to fill the user on the destination chain. And the user gets their fill, fast fill. The core insight is no message is sent between the 2 chains before the user gets to fill the user. The user is filled without a message going through. And this allows us to shortcut finality, shortcut all the messaging hurdles, and get the user filled extremely quickly. We then go and verify that the fill did in fact happen before we release the funds back to the solver. And so Across has been doing this in production for a few years now. Our median fill time has gotten down to 3 seconds. I actually think now we're 2 seconds between L2s, which is pretty cool. Costs are getting to be pennies or fractions of pennies. Actually, this number's old. And volume's now approaching 20 billion. We're like crossing 20 billion very shortly. Okay, cool. So we want to standardize this. And we have a lot of people pushing us, including the Ethereum Foundation, to help use standards to help move interop faster, move it forward faster. And our argument or thought process here is just like there's a common standard for tokens, that's the ERC20 standard. We know there should be a common form, or we think there should be a common form for intents, a standard there too. And y'all have heard me and others ranting about ERC 7683, a standard for cross-chain intents. I think it is worth going into what this standard does, how it works, and like what's the point here. So ERC 7683 is a standard that we created with our friends at Uniswap. We co-authored it with them. And at this point, we've gotten a lot of feedback from many, many other teams, too many for me to name right here. But here we go, sorry. We've got, I think now over 50 teams have adopted the 7683 standard, which has been like an amazingly cool reception that we've had. Incredible amounts of feedback. We've never really written an ERC before, so it's really, really cool to see it work out this way. It's been super fun. But like, what does it do? What does it look like? And in a second, we'll go into what it doesn't do, and then what are those things that we're moving forward to help. So my mental model here is to always think of this like an order ticket that I'm submitting to this network to just do the thing. And this order ticket, I'm stylizing this relative to what the standard looks like. But I'm basically saying, okay, what's my origin chain? What's my origin token and amount? And then what do I want on the destination chain? And a couple other things we'll talk about here in a second. But I write this order ticket and I send it to the network, and it just works. And it should be conceptually no different than I write my transaction and send it to the mempool, and it just gets executed. So this is the mental model, and this is working in production with Across. And there's very cool features we can add in here too. So just to make sure we're not thinking that this is just bridging value, you can bridge and like execute a swap or execute some arbitrary instructions on the destination chain. So bridge and swap for Frog token, buy an NFT, deposit into a vault. All of those are supported with one click. And we increasingly have very cool integrations showcasing how that works in Across today. And we're going to pull that forward with 7683. It also supports sending any arbitrary message. So this is where 7702 becomes really interesting. And we have built a demo of this that we need to clean up and put on the internet. But we can bridge funds and a 7702 message that we could execute arbitrary code on the remote chain, meaning we're setting the stage for a very useful form of chain abstraction here too, that many teams are interested in working with this concept to use as well. Okay. And 7683 also modularizes settlement. And this is kind of the key point and the key thing that's kind of new that I want to talk about in the last few minutes of the presentation. But this standard, this order ticket, it's not saying what the like how to escrow and verify funds. It's saying here's the shape of what my intent should look like, and then there should be some system, some Lego block I plug into that is going to keep users safe, escrow their funds, and only release them when the intent is fulfilled. But it is not opinionated on what that system is. And it can support superchain native interop. We are, in fact, working with the Optimism team to have a 7683 settlement contract that is going to get developed. Can support egg layer. It can support 7755 for storage proofs, and it can support Arbitrum's new broadcast standard, which is also using storage proofs. They put this out last week. The concept here is that the standard contemplates any type of settlement system, so we can plug in a wide like any new settlement technology will just make intents better when we're using this standard. So we go back here and like kind of look at this cake that I said before. What does this look like with standards, right? So once we add in 7683, we now say, okay, when you're creating the intent, we can specify it in this standard format, the 7683 standard. We then have solvers that are listening to the standard format specified by the 7683. So the solvers now are more useful. They can see more order flow. Anyone can write a 7683 standard for them to listen to. And at the bottom layer, there's still this settlement layer that is a module, that is a Lego block that we can plug into. Different systems can plug in there. And this is where there's sort of a need for more work. There's a need to standardize and move this forward for how we can really truly get these settlement systems that go to every corner of the Ethereum ecosystem and get us intents everywhere extremely quickly. And this is the basis of what we contributed or really pushed for around the open intent framework that we've worked long and hard with. The Hyperlane team led this effort, and we've worked with them and many other teams now with the Ethereum Foundation, pushing this concept as a continuation of 7683 and a way for us to get intents everywhere very quickly. And, you know, the framework does a few things, but it's basically taking 7683 and trying to really make it real and now, and really make it easy to write a settlement layer that you could deploy yourself. It could be permissionless. And this is just a screenshot from the GitHub repo that you can see at openintents.xyz. And as an example, a team called Bootnode, working with Hyperlane, has written this base 7683 settlement contract that allows you to plug in your own messaging technology to bring 7683 intent to any chain. And so now we're looking forward towards day one permissionless deployment of intents absolutely everywhere. And actually, I want to share just a few other things. This matches exactly what we've also pushed to production on the Across side in just the last couple weeks. So Across now also has 7683 in production. We got a nice doc site here that can walk through how this works. We have these contracts. So this is a 7683 contract that is deployed here. We're on base scan, and I really can use the 7683 methods and send intents on chain just using Etherscan, and they will get filled in 1 second, 1 or 2 seconds on the destination chain. This is like in production today. And so we'll go back to our presentation. 1 second. Sorry, guys. Get back here. Okay. So yeah, so we now have this this working in production, and we have this ability for the open intent framework to help bring us many, many settlement systems that teams can write and deploy themselves that fall in this 7683 standard. And now projects like Across, this improves us and makes us better because we can route intent order flow to settlement systems that cover all the corners of Ethereum land. Okay, so just sort of summarizing here, like, why are these standards helpful? So for developers, the 7683 standard is this common format, this order ticket to let you do anything cross-chain. This you just fill out this order ticket and it just works. For solvers, the standard is incredibly useful because solvers now no longer need to be customized for each different kind of cross-chain or intent protocol. There's one common format that they need to listen to with each protocol. And then for chains, the open intent framework kind of pulls this forward. So now if you're a chain and you're like a longer tail chain looking to get intents to your system today, there's going to be many options, many different settlement layers that you can use. And there's going to be innovation and competition to develop the best settlement layers that will serve those users too. And so like what's next here? We continue to be, I continue to think it's super cool how much broad support this standardization effort has gotten. The Ethereum Foundation has like leaned into supporting and helping coordinate the open intent framework in 7683, which I love because we now have real alignment that intents are important to unify Ethereum, and we can really push forward in that direction. So we want to like keep pushing for more unification, more consensus building about how we get intents everywhere to all the corners of Ethereum land. But we still need better dApp and wallet systems. I think a lot of the UX work still needs to get done on how we make the UX here better. And one of the things I'm most interested in is once we do have 7702, spelling error here, but once we do have 7702 with the Pectra hard fork deployed, how do we really push forward on the chain abstraction to make it feel like Ethereum is one network again? Anyways, guys, that's my talk. I don't know if we can do questions at all, and I also don't know if I'm talking to an empty room. I can't see you all, but thank you for letting me present remotely. I really wish I was there in person. Thank you to Ben and Jill, the Espresso team, for having me. Yeah, That's it. Let's unify Ethereum.
Thank you so much. People are clapping. People are cheering for you.
Sure.
If you can hear it. We have time for Q&A. We have like a solid 7 to 8 minutes spare. So I'll pass around the mic if people have questions.
Hey, Hart, Alan here for Boba. Great to see you.
I can't see you, but yeah, great to have my face on the screen.
Yeah, your face is on the screen. What does it take for a chain to support 7683? How do we get everybody on board?
Yeah, so I think in this ability, like we have this 7683 contract on base right now. This isn't a cross contract. I want to kind of refer to this as it's like, to me, we have this across settlement contract here that's getting deployed. We need this to be everywhere on every chain. And when I say across, I mean it's using our existing settlement system. What I think is so powerful about this architecture is now with, if we go to the intense framework here, we can write many settlement systems that aren't gatekeeped by any one party. So across this existing settlement system, can't permissionlessly add chains, but like this one could. And then all of a sudden across, we're just going to route to it. So I don't know if this fully answers your question, but I think there's going to be this explosion of innovation at this like settlement layer that's going to just let us support all these chains on day one using different messaging techniques. So for example, if it's a long tail chain that Hyperlane supports, we write a settlement contract that uses Hyperlane messaging to connect to them early on. Let me know if that's helpful.
Yes, he says thank you. Anyone else?
Hey, Hart, thanks. So as institutions, institutional assets begin to come on chain, is there a vision for like a regulated and compliant trustless ecosystem of solvers?
That's a good question. And like following the Bybit hack, there's a lot of stuff I've been thinking about there. So I think it's important to have permissionless systems. This is a little bit more of like a personal belief. I think it's important to have permissionless systems. And I do think you want to have a system that doesn't like enforce censorship. I think that can be kind of dangerous. However, we also want like good guys to not be like, we don't want solvers bridging funds for North Korea. I think we all kind of agree with that. Across today does a lot, and we do a lot to block bad addresses in our front end, which I think is pretty standard and reasonable practice. And we also block bad addresses in our solver. We kind of opt into doing that. I think that there is a useful and good way that we can have public goods around bad addresses that solvers can listen to and opt into not using, getting us a path like closer to what you're talking about. But I do think it's a complex issue, and it's something that we have to like think carefully about. How do you balance censorship resistance with being like compliant and doing good guy things? It's top of mind for me, very interesting. And so like, please ping me on Twitter or on Telegram.
Absolutely. Thank you.
Anyone else? We're still waiting for the next speaker to arrive. No, all good. Thank you so much, Hart. Appreciate it.
Thank you guys. Thank you so much. I really appreciate it. Thanks for having me. Sorry I wasn't there in person. Have big FOMO.